Hello everyone, welcome to our pre-calculus class. This is our lesson 21, Introduction to Quadratic Functions. So far we have discussed most of the things related to linear function. We are starting quadratic functions now. These are the agenda. Quadratic function, what are they? Why do we care about them? Element of a graph of a quadratic function, then practice graph over quadratic functions, then algebra for quadratic functions. We have review of algebra working with the parentheses. So these are some review work, application of factoring, finding the x intercepts of a quadratic function, and then some practice homeworks. Most of the things are related here. They are related to all of them are related to quadratic functions in different style, like why we use it, where we use it, and then what other different thing means in quadratic functions, which is like x intercepts and y intercepts, etc. So let's have a look. First of all, quadratic function. What is the form of a quadratic function? The form of a quadratic function is some form which is like, ax squared plus bx plus c, this kind of form, or just only x squared, like if we have the power, of x as 2, then it is quadratic. To be a quadratic, the power of x has to be 2. No more than 2, no less than 2. Okay? And here, bx plus c, these two things can be 0. But a cannot be 0. Or this term, in other words, this ax squared cannot be 0. If ax squared becomes 0, then the whole thing becomes, this part, bx plus c, becomes linear. Then it becomes linear. That's why ax squared, a cannot be 0, but b and c can. This part here cannot be 0 to be linear. Okay, to be linear. Alone c can be 0, alone bx can be 0, or bx plus c both can be 0, but this cannot be 0. So the main part here is this one, which makes this function as linear. So which one is linear, which one is not linear here? Remember, the power of x has to be 2. Okay, so look at which one is linear, which one is not linear. You will notice that this is x squared, so this one is linear. The power of x is 1, so not linear. The power of x is x to the power minus 1 here, or 2 divided by x, not linear. X power is 2, so this one is linear. This is 2 to the power x, which is not linear because our condition is x squared. This is x squared, so this one is linear. There is no x squared here, so not linear, not linear. So this blue color, only the blue colored functions are linear, others are non-linear. They are quadratic, sorry. All of them are quadratic. This one is quadratic, this one is quadratic, and this one is quadratic, and the others are not quadratic. They are different thing but not quadratic. The name comes from the Latin quadratus, which is to make a square. So this quadratic word actually came from quadratus, came from some Latin word which is related to square. Square. This is square. There is some relationship here with this square and with its name. The square related. The figure is this mathematics is related to the square. Say x and x, you have x squared. The area, x squared means the area or the space inside this box is the area. So they are somewhat related. All of them are somewhat related. So where we will use the quadratic functions? Here, this is an example. We have one example is business related, money earned, revenue. So you say the price of the product's price affects the number of units sold, demand. We discussed this demand function. Now revenue equals to price into the number sold. It means what? Let me show you that. Suppose you have 3 pens. Let's say you have 3 pens here. Hmm. So if one pen is 5 taka, then 3 pen is how much? Eh? So one pen is 5 taka. This is very simple example, but you will see this complicated thing also represent this. One penny is 5 taka. So 3 penny means 5 into 3. Okay. So one penny and each penny is 5 taka. This is the price. This is the price. And this is the quantity. There are 3 pencil here. This is quantity. So price into quantity is your revenue, is your total amount of money that you get after selling it. So here let's say this is our quantity function. This is the quantity function, and price, say we do not know. So price into quantity means this is the revenue. Now this math actually we will discuss later. This math will come once again. We are just showing you that where we use this math. Okay, so when you multiply price and the quantity, then you get some function, then you graph it. From the graph, actually this is the maximum point. From the maximum point we will understand a lot of things, and we can analyze these maths from different angles. So this quadratic function helps us to understand business related maths very well. And projectile motion also, you see, projectile motion means if something moves, suppose you throw a stone, suppose you throw something, then it goes like this. It goes like this. If you throw something, this motion is called the projectile motion. This motion is called the projectile motion. So if you throw some rock, if you throw some stone, if you throw some pen, or anything you like, then it will have this kind of motion, which is like, see, this kind of graph. Actually, these are the graph of the quadratic function, and anything that gets this graph, you can analyze it by quadratic function, which is rocket shapes, footballs, cannonballs, etc. All of them you can model by a quadratic function, and you can use your knowledge of quadratic functions. You can use your knowledge of quadratic functions to analyze that new situation. This is like a ship. Suppose you have some cannonball, you have some bomb or something that you want to destroy that ship. So you need to study this quadratic function, the path of this parabola. You need to study this path is called parabola. So the path of this path you need to understand, where you have to throw your cannonball. Okay, if you throw it too close, suppose if you throw it too close, then it will just hit here. It will be on the water. If you throw it too far away, then it will go outside. So this is a waste. You need to study if you want to put it on exact location. This study we can do from the study of the quadratic functions. Okay, so here these are the uses of quadratic function. Elements of graph of quadratic functions. So let me show you all of them. So first of all, what is the name of the graph of quadratic function? This, as I said, this shape is called parabola. This shape is called parabola, and this graph is symmetry. What kind of symmetry we have on this graph? So generally, if the function is something like say y equal to x squared, and if we graph it, then actually you will see the graph is this, something like this. So the graph will go through the origin. That's why the symmetry is, we are saying that the y-axis is the symmetry, for the parabola. But of course, for this parabola, y-axis is not the symmetry. It has another symmetry, which is called this line, which is actually this line. And we will study about this line a little bit more in the coming slides. Intercept. So it always has y-intercept. There is only one y-intercept, only one y-intercept. Think about it, why it can have only one y-intercept. But for x-intercept, it can have 0 x-intercept, 1 x-intercepts, or 2 x-intercepts. suppose this function here that I have drawn, this function has only one x-intercept and one y-intercept only. So in terms of x-intercept, you have only one here, but here in this graph you have two x-intercepts. But if you draw a graph like this, if you draw a graph like this here, then it will have 0 x-intercept. There is no x-intercept for this parabola. So that's why we are saying that it may have 0, 1 or 2 x-intercepts, but always has one y-intercept. Think about the reason for why it always has one y-intercept, and if you get some answer, let us know in the class. Okay. And the vertex is the point where the parabola gets the turning. So you see, this is the parabola, this is the vertex. After this vertex, the parabola starts going in another direction. So based on our regular approach, so you see, you come from left to right, so the graph goes down, graph goes down, graph goes down, graph goes down, up until here the graph goes down. Then after that point, the graph actually starts going up. See, the graph goes up, up, up. The graph goes up. You have to come from left to right. Or you can say, or else you will be confused. You will say, sir, this side also going up, this side also going up, this side also going up. Why you are saying that this is down, going down, and this is going up? Why? The reason is you have to maintain same direction always. Come from left side to right side. Then you will see that you will hit this line first. Then you see the graph is going down from that point. And suppose here, why it is going up, we are saying you hit a point, then after that point you go this side, then you see the graph is going up. Okay, so this is the turning point, and this turning point is very, very important for parabola. This is called vertex. Vertex is the turning point, very important, very important. And for this graph, this is open up, this is called open up opening, and because upside is open, this is called open up parabola. For open up parabola, this point is the lowest. After this point there is no other points, so this is called the lowest. And if you have a parabola like this, open down, then this point will be the highest. So sometimes this vertex can be highest, sometimes this vertex can be lowest. It depends on, is it open up or is it open down. How come a parabola is open up? How come a parabola is open down? We will discuss it. Okay. So vertex is very important. Remember, of course, intercept and other things also important, but you will see vertex is playing a major role. Line of symmetry, as I said, from my graph, it was like y-axis, axis of symmetry, line of symmetry. But for this graph, for this given graph here in the line of symmetry is this line. This line is called x equal to 1. This is x equal to 1. This line, because it is 1. So x equal to 1 is in this question. Let me use the black color. So x equals to 1. X equals to 1 is the vertex of axis of symmetry, line of symmetry for this parabola. Now say if the parabola is here, I'm just drawing it randomly. This is too random. Let me make it, suppose, yeah, this is better. Suppose this is my parabola, somewhat, okay. This is 5, so this has to go through something like this. You know what, while I'm drawing, I have to think about many other things also. They must match with everything. Anyway, so if this is the vertex, then axis of symmetry or line of symmetry will be this line. So the line of symmetry, what will be the equation of the line of symmetry? Equation will be, this is -1. Oh my god, the line has to go through. Okay, so this is -1, -2, -3. So x equals to -3. X equals to -3 will be the line of symmetry here, because this is -1, -2, -3. This line is going through the x equals to -3. That's why. So the line of symmetry is this. In other words, line of symmetry will always come from, there is a trick. The line of symmetry will always come from the coordinate of the vertex and x value. So, for example, suppose what is the coordinate of this point? 1, comma, minus 4. So 1, comma, minus 4. Okay, and this 1 will be the line of symmetry. X value of the vertex will be the line of symmetry. Okay, this point is see, minus 1, minus 2, minus 3. So this point is minus 3, comma, plus 3. X value will be the line of symmetry. X value of the vertex. Okay, so this way we understand it. Yep, this is the line of symmetry. So try to find out the intercepts, vertex, and line of symmetry for each of these parabola, for all of them, and then match your answer with our answers. These are the answer. So yeah, for the blue line, so this is the x intercept, y intercept, vertex, and line of symmetry. And for the other lines also, you may go ahead and solve it when you have if you have different problems. We can discuss it, or we can verify our answers, okay, during the class. Now we need to review a topic which we think that, of course, most of you are very good at, but let's look at this thing. When you multiply x and this, what will be the answer? Very simple thing, but you see, so 5 into x means 5x, and then x into x means x squared. So this line will become 5x minus x squared. Then when you have two quantity like this, some term here, x plus 2 and into x minus 4, how do you multiply it? So first you can do it, x multiply the both thing. Let me show you one. So x into this whole thing first you do. So x into x means x squared, then x into 4, that means minus 4x. So we finished multiplying with this x and this whole thing. Now let's multiply with plus 2 and this whole thing once again. So now we are multiplying plus 2 and this whole thing once again. So plus 2 into x means plus twice x. Then 2 into minus 4 means minus 8. So ultimately we have x squared minus, so see, minus 4x, twice x. So we have minus twice x. Then minus 8. Okay, so this is what we get after multiplication. These are the answers of all of them. So this part is when you multiply, then this is the answer. So now suppose this is given, how can you go back to this kind of thing when this is given? So you have to do some kind of reverse engineering. Here you have to take the common, here you have to do the middle term factoring, like that. So give a try to get this answer. If you get it, these are the solutions. Okay, so these are the solutions, and this is one. Let me go back and connect it. So this is one important thing to notice, that actually when you have x and 5 minus x, or x plus 2 and x minus 4, actually this kind of thing, they represent the x intercept. This number, this is plus 2. So minus 2 represent one x intercept. This is minus 4, and plus 4 will be the x intercept for this question. So minus 2 and plus 4. This is, if it is plus number, then the minus, and if it is minus number, then the plus. They will be the x intercept. They will be the x intercept of this expression here. And if I write y equals to, then it becomes equation. If you graph it, you will see from the graph, minus 2 and plus 4 will be the x intercept here. And that is why, suppose you can say, sir, why you are doing all this thing? Because we want to understand the x intercept of this given problems. So they represent the x intercept. And why minus 2 is the x intercept? Because of the zero product rule. If you write this equals to 0, then you have x plus 2 equals to 0. Same concept will go for other maths also. That's why I'm just coming back to this slide once again and again. So x equals to minus 2. This is the x-intercept, because at x-intercept y equal to 0, y equal to if you write y equals to this thing, so y equal to 0 x-intercept, so we put this equal to 0, then we try to find out x equals to what. Simply, as a technique, you can think x plus 2. If you get x plus 2 and x minus 4, this kind of thing, from the factoring of quadratic function, you will always, this technique will work. You can say, if it is x plus 2, then minus 2 will be the intercept. If it is x minus 4, then plus 4 will be the intercept. And same thing will go for them. Same thing will go for them. So that's why we are saying that this is x plus 1, x plus 2, so minus 1 and minus 2 will be the x-intercepts. Okay. To get the x-intercept, we put this at 0. If we put this at 0, then we will get this solution. And from where this comes from this this quadratic function. This quadratic function x squared plus 3x plus 2 by using the middle term factoring. Check it out if you get the same solution or not. Then where is the application of that thing? Suppose we learned this thing. Where is the application of this thing? Application of this thing is, let's say you have x squared minus 6x plus 5. This is a given function. So what is the y-intercept? What is the x-intercept? Okay. So you will have, if you put x equals to 0, so 0, 0, so plus 5 is the y-intercept. So you will have the plus 5 here. This is the y-intercept. And to get the x-intercept, you just do the factoring here, then you will get the 2x-intercept. This is the, so x equals to 1 and x equals to 5. This will be the 1 and this will be the 5. By using the zero product property. And if you try to see, if you put f equals to 1 and f equals to 5, what you get from this given function. Okay. So where it helps? It helps us to identify the x-intercept. This x-intercept. This is 1 and this will be the 5. This x-intercept. This one and this one. And then we said that y-intercept also 5 here. This is the y-intercept. 5 is here. How do you get this 5 y-intercept? If you put x equals to 0. How do you get the x-intercept? If you put y equal to 0. Y means fx. If you put this side equal to 0, then you get this 2 value. If you put x equals to 0, then you get this value. Simply, if you want to get the y-intercept, you put x equals to 0 in the function. If you want to get the x-intercept, you put y equal to 0 in the function. And do the calculation. This is how it works. This is the homework. So try to find out by graph, by plotting points, find the vertex, line of symmetry, etc. from this thing, and find the intercept, x-intercepts by factoring for this given functions. Just practice homework, okay? And that's all for today. So see you all in the class. Thank you very much.